there are two important mechanisms for converting numbers in Java. So one mechanism is automatic, called coercion, which we're going to speak about right now. The other mechanism is manual, which means it has to be done by a programmer. It's called casting, and we'll speak about it after coercion. So what's coercion really? It's implicit and automatic, which means you don't need to do it by yourself. Java runtime will do it for you. And it's called automatic type conversion. And then, so how does it work? So Java automatically converts an integer value with no fractional part into a real number, like a floating point. Basically, from a value without any fractional part into another value with a fractional part, when necessary, which adds a fractional part. Okay, let's see exactly how this works by examples. Let's see over here. So we have over here we declare some variable called value1 of type double. Right? Let's worry about this one first. And on the right hand side, you can see this is the source for the assignments. We are trying to do multiplication. Is this type correct? It is, because we are trying to multiply number by number. However, because you can see, try to be more precise over here. This 3 over here is an integer, right, with no fractional part. This 4.5 over here is actually a double, like a floating point number. So what Java would do is actually going to say, before you try to do the multiplication, if you got at least one side that actually has a fractional part, that means the other side must have a fractional part as well. If it doesn't, then it's going to add it for you. So what's going to happen is the 3 over here is actually going to be coerced into 3.0. So this is called coercion. Coerced into 3.0. So this is one instance of coercion. So after this, you're going to have 3.0 multiplied by 4.5. So which means for value 1 is going to store 13.5. Okay, so that's the first instance of coercion. Let's see the second one. What about, of course, you can simply reveal this. Actually, you will see that. So you will simply see that 3 is actually coerced into 3.0, right? That's exactly what I just illustrated. 3 is coerced into 3.0 in order to do the multiplication. So what about the second one? The second one over here, you can see we got addition over here. You can see we got 7 plus 2 as the source of the assignment. So now for plus, remember it can be either concatenation or it can be addition. In this case, because both sides are simply just integer. So numbers, so we're going to do addition. That one there, nothing to coerce just yet, because it's simply, both sides are simply integer. So we're going to get 9. However, when you're trying to store 9 into value 2, which is declared to be a double, remember double is actually a data type where each value has a fractional part, right? It's a floating point number. So fractional part is always present. So that means when you actually create this particular box for value 2, right? Whatever value you store over here, it must has the form integral part, point, fractional part. So now we only got 9. So what should we do? Easy. Integral part just be 9, and then fractional part we'll just say 0.0. Mathematically speaking, they are equivalents. So now, the process of going from 9 into 9.0, that's the second instance of coercion. So 9 is coerced into 9.0. Okay, so now if you reveal this, you can see that as well. You can also see this in your slides. Okay, so that's about coercion. So you coerce from integer automatically to a floating point number when necessary. Let's consider another. So that's about coercion. We are done. Okay, let's consider the motivating example for casting. Let's consider a scenario like this. We declare value 1 to be of type integer, which means integer here has no fractional part, right? That's really the fundamental difference between integer and floating point number. No fractional part. So now if you try to do this one here, we know that 3 is going to be coerced to 3.0 simply because the other operand is 4.5, which has a fractional part. But if you do this, overall it's going to be 13.5. So now, if you try to store if you're trying to store 13.5 into value 1, it's not going to be type correct, because remember, whenever you want to assign some value into some variable over here, the value must be compatible with the declared type. So now 13.5 is not compatible with integer. Okay, so this is not compatible with integer, simply because the 0.5 over here is not allowed for integer type. So this will simply not compile. And please feel free to try on your Java project to make sure Eclipse will actually give you an error if you do this. So now, how can we fix this? Potentially, to really fix this, it would be very nice, rather than storing 13.5, because the box over here, the placeholder for value 1, over here, actually, it can only accept integer, right? Integer only, because it's declared to be integer. So now, rather than storing 13.5, is it possible to store 13.5 but with the 0.5, the fractional part, truncated? Is it possible? It's not the same number anymore, but as far as the integer is concerned, you can think about the integer over here. You're trying to extract the integral part of the floating point number over here. So the fix will be to extract the integral part of the number. Okay, so however, the compiler wouldn't do it for you. You will have to do this manually and explicitly yourself. So this is something called casting. All right, let me go back to the slides and then we'll do examples together. So that's about the coercion example that we spoke about, and this is the motivating example for doing a manual casting. And the manual casting is actually going to, this one is not going to be compilable, where we explain it, and we need a way to truncate the fractional part, or we need a way to extract the integral part, as I also wrote it down on the notes. Okay, so now how can we do it? So now we talk about casting, right? Really don't get confused between coercion and casting. Coercion is really trying to add fractional part. Casting is trying to go the other way. We are trying to remove the fractional part. So it's going to be explicit, something you have to write it down explicitly as a programmer, and it's a manual type conversion. So usage number 1, I will give you more example in just a moment. So there are two scenarios where you may want to do casting. Okay, for the casting over here, you want to assign a real number to an integer variable. So this is exactly the usage they talk about. You just want to remove the fractional part. Okay, in this case, you will simply just say, I want to assign 3.1415926. I cannot store this value directly into this integer variable because it got the fractional part. So if I can just truncate it using a explicit cast. So this is the syntax. Okay, so you're gonna have opening parenthesis over here, and also closing parenthesis. Inside, you will tell the compiler what type you want to cast it into. In this case, cast into integer, meaning that we're going to extract the integral part for this number, which would be just 3. Okay, let's see more examples. Okay, let's see over here. So so the case number 1 is simply want to go from double into int by removing the fractional part, right? That's the casting. So now let's consider one by one. Let me just number them. So we actually got 1, 2, 3, 4, and 5. Let's consider them one by one. So what about number 1 over here? Is number 1 compilable? It does not compile, because this has a fractional part which cannot be stored into integer, right? So this does not compile. Okay, and number 2 will compile, because after this explicit cast, you can see opening parenthesis, closing parenthesis, and then we want to cast into integer. So what this will do over here, so the whole thing over here is going to extract just the integral part, or equivalently, we're going to remove the fractional part. So this part here will just give you 3. So that means value 4 is going to store 3, right? You can think about value 4 over here, the variable of type integer is going to store 3. Okay, so 1 is not okay, but 2 is okay. Let's do a little bit further. Let's see over here, we got a double variable, value 2. This is okay, right? You simply declare value 2 to be storing floating point number, and we do have a floating point number here, 3.14. Okay, that's a number. And let's try to see this. And first, we now declare another variable over here. We call value 3. Okay, value 3 over here. Okay, value 3 is declared to be of type integer with no fractional part. And now you're trying to initialize value 3. Remember we talked about when you got right hand side the source as the variable. That means you intend to copy this value over here into over here. Is this valid? Apparently it's not. So it is not going to compile because value 3 is only supposed to be integer. So you cannot store this value over here with the fractional part. But if you do a cast explicitly, it would be okay. So you can see the next one. The next one, number 5, would be okay, right? Because if now you try to do another variable over here, just integer variable, value 5 over here. So now you're saying that before I try to assign any value to value 5 initially, I'm just going to see whatever that is stored in value 2, which is this number over here. I'm going to cast that into integer. So I'm just going to cast that into integer by removing the fractional part. So the fractional part is simply here. Remove it. So we will just get 3. And 3 is then, so this whole thing over here, this cast over here is going to be 3. And then we're going to copy the 3 over here into value 5. So this will store 3. Alright, hopefully you can see that, right? Exactly how we can do cast. So the case number 1 for using casting is go from double to int. Okay, and scenario number 2. Okay, however, for casting, you don't necessarily always just want to do from double to int. You may actually want to do some manual casting, but you can think about manual casting on the other way. You can go from integer to double. Remember we talked about coercion. Coercion is something that Java would do for you automatically. But there might be some scenarios that Java wouldn't do coercion for you, but you may just want to do it yourself. But you don't call it coercion, because whenever we talk about coercion, it's really something that's automatic. But the kind of int to double conversion I'm going to do has to be manual. You have to do it explicitly. Let me show you exactly what I meant. Alright, let's now move on to the slides, and then I'll show you the example I want to go over. Okay, usage number 2. So now you may also use explicit casting. So here the casting here is really do the other way. We want to go from integer to double. But why do we want to do it, right? Let's now consider this particular value over here, right? What would that print to the console? Alright, I got 6 different versions. Let's consider one by one, and we'll see why casting an integer explicitly to a double may serve its good purpose. Okay, let's see the first one. We got division over here. Remember, I spoke before. Whenever you want to do division, we got 2 cases, right? You can refer to the previous notes. If both sides are simply just integer, it's going to give you the quotients, right? So now, what would that give to you? Well, the quotient would be just 0, right? Okay, hopefully this one is okay for you, right? So you simply just give you just 0. On the other hand, you can also say 1 modulo 2. That will actually give to you 1, right? You can combine the remainder and also the quotient together, as I spoke about already. So now, how can I say I really want a number with precision as a result? For example, I really want 0.5. How can I do it? Okay, so now I can say explicitly I want to cast maybe one of them. So remember, for division, as long as one of them at least one of them is actually has a fractional part, and then the result is going to be with precision. That's what we said before. So now I just need to explicitly cast either. Okay, let me show to you. So we got different combination. That's basically the next several example over here. I can either choose to cast the 1 over here, or I can choose to cast the 2 over here, or I can choose to cast both. Okay, over here. I can choose to cast them. And notice what I'm writing over here. So I'll write it a little bit better for you. You can think about this guy over here. It's really to say, originally it's simply just 1, right? I want to cast this particular integer into 1.0, right? I want to make sure do this cast first before you do anything else. So that's why you can see this parenthesis, this pair of parentheses is forcing the order of evaluation, and this part here is doing the cast. And overall, it's going to give you 1.0. So now if you say 1.0 divided by 2 is going to be 0.5. Right? It's going to work. And then similarly, so now we got 1 divided by 2.0. Right? It's also going to give you not the integer quotients, but the result with precision. Pretty much the mathematical result you would expect. Or you can also try to do 1.0, 2.0. Both have been cast to double explicitly. So that'll be also 0.5. Let me show you another alternative if you like. Rather than writing the literal directly together, what you can do is, if you the idea would be as long as at least one of the operands is not integer, it's actually a floating point, then it will give you the result by precision. For example, let's say if I say double value 1 is equal to 1. Also, you know what? Let me just put it like that. Okay, that'll be enough. You can you can also declare more variables if you wish, but you'll see some later examples similarly. So now if I simply say v1, so system.out.print line, and then I want to print out v1 divided by 2. So the only change I made, I just say v1 rather than just 1. So now what would this give to me? So this will actually give to me, you can see v1 over here, it's actually a double, right? Remember coercion. So this 1 over here will be coerced to 1.0. So that means this will be simply 1.0 for the double, right? Because here integer, but that will be coerced into double, right? So 1.0. So that will give me 0.5. What if I got another possibility over here? What if I say integer, let's say v1, let's say v1a. Let me just use a different number here. Let's say v2. Okay, v2 over here. That's also 1. First of all, there will be no coercion because it's simply integer to integer, no coercion. And then if I say print right now, if I say print v2 divided by 2, am I going to get 0.5? The answer is no, because you can see this part here is integer. This part here is also referring to some integer. So now overall it's going to give you the quotients. So now this one here is going to give you 0, right? So these are just extra examples to show you. Okay, hopefully that makes sense. 2 more examples to show you. Okay, 2 more about the casting. The first one over here, you can see, let me show you both of them together. You can see we are trying to do cast double over here. We are also trying to do cast over here. However, the difference is this. We are basically doing double here, and then 1 divided by 2. And also double, and then 1 divided by 2, but in the parentheses. Okay, let's see the easier one. This one over here, so the fact that we put parentheses means we want to force this particular part to be evaluated first. So every time you put a parenthesis, pretty much in your math, you want to force the order of evaluation. Pretty much like if you say 2 plus 3 multiplied by 2 plus 3, for example, right? So now we know that implicitly we're going to do 3 multiplied by 2 first. But what if I want to do 2 plus 3 first? In that case, I would just need to force the evaluation. I'll put a parenthesis, the similar idea over here. So let's go back to this example here. So now we got this part to be done first. 1 divided by 2, as we know, is going to be 0, the quotients. So now, if you cast 0 into double, it's actually going to give you simply 0.0. Okay, that's why this part here would just be 0.0. But what about the previous one? The previous one, interestingly, so that's something called precedence. Okay, precedence simply means which operator has higher precedence. For example, the multiplication has higher precedence than the plus, right? So now the cast over here has higher precedence than the division, which means when you write an expression like this, it is as if, let me write it down here. So when you put double over here, and then 1 divided by 2, okay? So the casting operator is actually has higher precedence than division. So it's as if you actually wrote double 1, do this first, divided by 2. So this part here is implicit. So these two expressions are simply equivalents. Let me say it again. So the casting operation actually has higher precedence than the division, just like the multiplication operator has higher precedence than the addition operator, right? So now, writing this will be as if you actually put the parenthesis around the casting to 1 on 1 first. So what would this do? So what that would do is, let me write it down here. So that would be, so you're going to cast this part over here to be 1.0, right? And 1.0 divided by 2 is going to be 0.5. Okay, that's why it's actually here. All right, so you can see we got 6 examples over here to show you the motivation for the scenarios where you may just want to cast from integer to double explicitly. Notice that this is not coercion, because whenever we talk about coercion, it must be automatic. But now this is only manual. And the reason that we want to do manual casting in this case is because we actually want to gain the result with precision. That's why. However, you want to be very careful. For example, if you do something like this, where you try to do integer division and then you do casting, you're not going to get the precision you like, right? Be careful. You are expected to know such tricks. That's why you want to study this carefully. If you got questions, ask me in the Q&A or office hours. Okay. So now I would like to conclude this particular topics by doing more examples with you. I think practice makes perfect. So let's just study more examples. Now this one is also on your slides, but I want to go over with you line by line. Let's try to trace this Java code line by line. And then the best way to trace it is by visualizing the variable that's involved by using boxes, right? Let's see the first one. The first variable we have is D1 of type double. And this is the first one. Let's visualize it. So over here we got D1 of type double. And then it has this value here initially, right? There's no coercion, right? No, because you just simply storing floating point into double. No coercion. 3.1, let me write more legibly. 3.14. Okay, that's the first line. And then when you try to print out, D1 is, and then simply just D1, right? So that will be D1 is whatever value it is over here. Okay, that's the first one, right? Hopefully so far so good. Let's see the second one. I say double D2 is assigned, is initialized to be whatever that's stored in D1. That one is not too bad, right? Again, no coercion is done because D1 stores double value already, so there's no coercion. So that means D2 over here meant to be storing double, but it's going to copy, in its initial value is going to copy whatever that's stored in D1. Copy over, you got just the same value. Okay, just the same value. So now when you say print out D2 is, right, it will just be the same value. So it's going to be D2 is the same. All right, let's move on. The next one, let's use orange. So now let's say we try to do this one over here. So we are trying to basically cast. You can see D1 basically store this particular floating point number. We want to cast that into integer. So this is a manual cast, removing the floating point part, right? So now this number here, with removing the floating point, we're going to get 3. And then we'll store 3 into I1, right? So that compiles. So now we got I1 over here, and that one has 3, okay? And then we're going to say I1 is here, I1. So I1 store value is simply 3. All right, let's do more. Let me use pink over here. So D2 is reassigned, right? You can see it's not declaring the same variable anymore. It's not declaring. It's not redecoration. You just cannot do redecoration. It's reassignments. So what we want to do is this. So now you can see I1 multiplied by 5. Let's think about it. Is there any coercion happening? The answer is yes, because I1 over here is really 3, so it will be coerced to 3 point. Oh, I beg your pardon. Let me say it again. I beg your pardon. There is no coercion, because the way to really see if there's any coercion is by looking at this. You can see I1 over here is integer 3. And then we're doing multiplication. What's the other operand? It's also integer. Integer multiplied by integer. There is no need for coercion. So sorry about that. So it should be no coercion. So now this will be 3. 3 times 5 will be 15. So the I1 itself, no coercion. However, coercion happened next. Okay, let me use another color over here. How about purple? So here you can see this part over here. We simply got 3 times 5, which would be 15. But D2 over here, remember D2 was declared to be a double. So now if you want to store integer into a double variable, right? D2 here is a double variable. So now there will be coercion. So now when you do the assignment, 15 will be coerced into 15.0. All right, so now that means T2, rather than storing this, is going to be 15.0. So now when you print it out, D2 is whatever. So it's going to be D2 is 15.0. All right, so now that's how you trace the program. Hopefully everything makes sense. Let's do the final set of examples here. Let's just do as many as we can, right, to really help you understand. So now we want to judge to see if things are type correct. If it is type correct, it will compile, and then we'll see what the consequence is as far as programming is concerned. If it is not type correct, we're going to explain why not. Okay, let's see one by one. The first one, is it going to be type correct? Line number 1, right? Over here. This one seems to be type correct because we're going to store integer into the double. What's going to happen is there will be coercion, right? So this will be coerced to 23.0, and then D1 will contain 23.0, right? Okay, so that means D1 is going to store 23.0. So what about this, the next one? The next one here, it seems like it wouldn't compile because you're trying to store floating point number into an integer without a cast. So that's not good. Okay. And then what about this? We declare S1 to be a type string, but we're using a character over here, character literal. It's basically a character literal with only a single empty space. So that's not compatible, right? You cannot store character into string. So that's also not good. Okay, you will see the detailed explanation in the slides as well. Let me now just give you more intuitive explanation. And similarly, you can see this is a string literal. So this is a character. And this is a string. Again, this is not compatible. You cannot store a string into a character variable. So that's also not good. All right. So only the first line is actually type correct. Let's do more. What about the next one? Line number 1 over here. It seems to be okay. You can see 23.6. We want to store into I1, which is integer, but we try to do casting first, right? So what that will do is the entire expression over here after the cast is going to remove the fractional part, which will be 23. So after this, I1 is going to store 23 over here. And then if you try to go further, so I1 multiplied by 3, there will be no coercion over here. I1 is integer, 3 is also integer. No coercion is to be done. So this part over here, let me use a different color here. So you can see this part over here, I1 multiplied by 3 is going to be 69, right? But now you're going to store 69 into a double variable, so it will be coerced to 69.0. So that means D1 over here, a box, which is going to store 69.0. Okay, and let's see another one. What about the next one? Next one seems to be compiling. Okay, this one compiles. We already explained it. And this one also compile. This is a string literal over here and store into S1. So that means S1 is going to be la with a space. And then we have S2 over here is going to be whatever that's in S1 plus la length, right? Basically, you can see what I'm doing here. So basically, plus is going to do concatenation for both strings over here. So that one is going to be S1 is going to be la over here, and then la length over here. Okay, so this is also fine. Okay, so this is okay, okay, okay. This is also okay. What about the final one, I1? Okay, so now hopefully you can see that already that's not good. You can see here S2 multiplied by D1. This doesn't make sense. S2 is a string. D1 is a double. You cannot apply multiplication in between. So this part over here is already not type correct. Okay, you simply don't know what type it is. Even though this part over here, when you try to add up I1 plus D1. By the way, if you try to do this one, let's see just for this subpart, what's going to happen? There will be some coercion because I1 is 23. D1 is 69.0. So that means I1 over here is going to be coerced to 23.0. Right? So overall, after the addition will be 23.0 plus 69.0. You're going to get 92.0, right? Okay, so that's this part over here. However, no use. Even though this part here is actually type correct, but this part here is not type correct. So there's no way for you to figure out how to do this particular addition, right? Simply the type for this left hand side, left operand is simply unknown. So overall, the conclusion is this line over here does not compile. Okay, but I just want to do some detailed analysis together with you just to make sure you understand it. All right, so for every example I talk about over here, they are not really in the imported Java archive project archive. So I will encourage you to really try these examples in the Eclipse yourself and try to modify them if you wish, just to see what the alternative consequence might be. All right, so that's about the example I would like to talk about. Let's see if there's anything else. So these are all the scenarios about casting that I spoke about. And that's the tracing I did together with you. You can just double check it. And also this is basically the two example about type correctness. Okay, I also spoke about them in detail with you. All right, there's a second example. Okay, so that's about the topic for coercion versus casting. So the number one principle to remember, coercion is automatic and casting is manual. And then for the casting, you may either want to cast manually from integer to double if you want to gain more precision, or you want to cast from double into integer if you want to make the proper variable assignments.